So, for our next example, Tim extends a 90-day loan at 6% on July 29th. So what he's done is he's given a loan to someone else for $35,000. On September 2nd, Tim discounts the note to the bank at 8%. Find the maturity value of the original note. B, the discount period. And C, the proceeds. So step 1, part A. Maturity value of the original note. How are we going to find that? I equals PRT. So 35,000 times 0.06 times 90 over 360. Which will give us what? What is that? 5250? 5,250? Or 525? $525. Is that our answer? Say no, yeah. The maturity value is 35,000 plus 525. So $35,525 is the maturity value. Part B, step 2, discount period. We have a couple of dates there, July 29th and September 2nd. Looking at the chart, July 29th is 210. September 2nd is 245. 35 days. Is that the number we want for our discount period? Say no. What do we want? That's the amount of days gone by. We want the number of days left. 90 minus 35 is 55 days for our discount period. Questions so far? So now what? Proceeds. Find the proceeds. We got to do a sub-step here. Sub-step is find the discount, which is basically it's an I equals PRT. We're going to take that $35,525, the maturity value, times what is the discount rate? 8% times discount period, 55 days. 55 over 360. $434.19. What do you think? I'm not done yet. Good. What do we need to do yet? Yeah, we got the 35,525 minus 434.19, which will give us $3,590. No. How much?
35,090.
Yeah, it is 90.81. There we go. That's the proceeds. What do you think? Good stuff? That's probably one of the hardest problems on the test, by the way. Just so you know. There'll be a couple of those I just don't feel like doing anymore. They're long and you got a lot of steps you got to remember. And the biggest mistake people will make is right here in the discount period. I bet usually about a third to maybe half of the class, depending on the semester, they'll put down 35. They'll forget to subtract it from the length of the loan. Don't do that, or you die. Okay. Next. Sam takes out a simple discount note. For 1 year for $12,000 at 9%. Part A, find the bank discount. How do you do that? I equals P R T. 1 year is 1 for time. So what is that? $1,080 for interest? So that's the bank discount. $1,080. Step 2, part B. Find the proceeds. How do you do that? Yeah, 12,000 minus 1,080 equals 10,920. That's proceeds. And here's the part everybody loves. The effective rate. I'm going to show you a shortcut that we didn't do back when we were doing these like 4 weeks ago. So the effective rate, R, is the discount over the proceeds times the time. And make sure you put these in parentheses when you use this in the calculator. So on the calculator, what you're really going to put in, R is equal to 1,080 divided by, parentheses, 10,920 times 1, close parentheses. Yeah, let me try that again. I screwed it up. So 1,080 divided by 10,920 times 1, close. 0.0989, which means 9.89%. So instead of 9%, it's 9.89% is the effective rate. Any questions?
You don't want to round up?
Nope. It'll tell you in the problem round to the nearest 10th or 100th or whatever. If it said 100th, you'd leave it as 9.89. If it said 10th, of course, you'd make it 9.9.
They said not to round to the nearest hundredths. So
Yeah, normally I say hundredths. It might say 10th, whatever it says in the problem. It'll tell you in the problem.
That was 989 repeating, wasn't it?
Nope.
Oh no, it wasn't. Oh, it wasn't.
Nope. 0.9890. So we're good. Next.
Effective rate's like 10 from,
What?
like effective rate's like 7 from 20 years.
Kind of, yeah. So let's say Debbie Different Debbie, not you. Deposit $7,000 at 9% compounded quarterly for 10 years. Find the balance. In other words, find the future value, right? What type of problem is this? This is actually the first problem we've run into now that is not simple interest. This is compound interest future value. How do we know? Single payment. One big deposit. No payment. No regular payment. Annuity has a regular payment. Yeah. So her future value will be 7,000 times 1 plus 0.09 divided by 4 to the power of 40. Quarterly is 4 times a year times 10 years. That's where the 40 comes from. So 7,000 times 1 plus 0.09 divided by 4 close power 40 equals 17,046.32. It's 2.25%. Yeah, so you look that up in the table. Yep, that'd be one of them. But this formula is so simple, why not use it? I know. I understand. Are we ready? Casey deposits $9,000 at 8% compounded monthly. Find the effective rate. You might be saying, well, he doesn't tell us a period of time. Why did I not?
1 year.
1 year, you got it. Monthly for 1 year. So, we're going to find our future value of that $9,000. So, times 1 plus 0.08 divided by 12 to the power of 12, because we're only going for 1 year. 9,000 times, open, 1 plus 0.08 divided by 12, close, power 12. 97.46, 97.47. Because it's 99 cents, but rounds up. Everybody see where that rounds up to 97.47? Okay.
You wouldn't keep the cents? That's right.
It's 99 cents, 90.995, so that rounds up to 00. Now what? That's the future value. We only care about the interest. So we subtract to get $747 in interest. Now we can do the effective rate. R equals that interest of 747 over the principal of 9,000 times 1. So what we're going to put in our calculator, 747 divided by parentheses 9,000 times 1, close parentheses, equals 0.083. So that's 8.3%. Yep, I know. I'll put you back on here in a second. Well, let's keep her rolling. Lenny believes he will need $12,000 in 8 years. At 7% compounded semi-annually. How much does he need now? $12,000 divided by 1 plus 0.07 divided by semi-annually means 2. You got it, to the power of 16. Semi-annually for 8 years is 16 periods. Gives us 6920.47. There it is. What do y'all think? What's that? That's it, yeah.
What was the formula for that?
Present value plus future value divided by parentheses 1 plus r over n to the power of n times t.
Is that our compound?
That's your, yep, present value compound interest, yep. Okay. Next. Joe wants cool half mil in 25 years. How much each month at 5%? So if we get 5% interest, how much does Joe have to pay in each month for 25 years to get $500,000? What formula are we going to use? It's an annuity. You got it. It's an annuity because we're making regular payments. Whenever there's regular payments, it must be an annuity. Liquidation or accumulation? Accumulation. He's paying in. The lump sum is at the end. The big 500,000 is at the end. So that means no extra term. But since he does have the lump sum, the 500,000 is divided by 1, 2, 3. 1 plus 0.05 divided by 12. Close to the power of 300. Yep, 12 times 25 is 300. Minus 1. Close. Divide by. Open. .05 divided by 12. Close, close. Which gives you perfect. 839.62. Questions? Cool. Bob has 300,000 saved at 8%. How much can he draw each month for 20 years? Liquidation or accumulation? Liquidation, they're paying out. They have the $300,000, they have the lump sum at the beginning, and we're paying it out. What's that mean to us? We're going to divide because we have the lump sum. It also means the extra step at the end. This is monthly, so divided by 12. Power of 240 minus 1, close, divided by open. 0.08 divided by 12. And we do have to do times 1 plus 0.08 divided by 12. To the power of 240, close and close. 300,000. Oh, that might cause problems, huh? Thank you. You said something this time.
I missed one before?
Yeah, last week you just let me finish typing and then said, yeah, I saw that. Yeah, it's okay. I was getting ready to run you down the parking lot tonight, but since you did that, I guess I'll let you live for another week. 2519.32. Is that what you get? 2519.32?
Yeah.
Yes?
0.41.
What's that? 0.41?
Yeah.
Really? 2509.41?
Yeah.
I guess we can live with that difference, but yeah, let me try it again. I go 8 divided by 12 times. Same thing as me? Okay. Brooke says you're wrong. Yeah, I got the same thing again. So you
How
did
would I get
something.
a number so close? Like, so long?
I have no clue.
No.
No. That one. I'd have a better idea if you were way off, to be honest. Your calculator's just messing with you. What would happen if I do this?
Can you do it again?
I'm gonna try it and then
So there might be a couple more of those, but then we're going to run into ones like this. Kate wants to retire at 65. She would like to draw $4,000 each month and plans to die at 82.
Wait, what happens if you like say you're like stuck in the game and have all this money saved in your
So if she can earn 10% while investing, and 5% while drawing, how much does she need to put away per month starting at 28? So remember, we have this retirement thing in the middle here. On each side, we have two things. We have time, rate, and amount. Well, in this case, we have the time on both sides. On this side, it's 28 to 65. On this side, it is 65 to 82. We have the rate on both sides. Over here, it's 10%. Over here, it's 5%. The only amount we have is 4,000. Which side is that on? Drawing out. They want to draw out 4,000 after they retire. So we have everything over here. So that's where we're going to start. You look confused. You okay? Yeah. Oh, gotcha. So we're going to start out with that 4,000 a month times, since that's a monthly payment, 1, 2, 3, 1 plus 0.10 divided by 12. How many years is that? 17, and of course times 12, that would be 204, right? Minus 1, close, divided by open. 0.10 divided by 12. Do we need the extra term? Yes, we do. Times 1 plus 0.10 divided by 12 to the power 204. Close and close. I get 391,692.03. Is that what everybody else came up with? Yes, I know I got it. Very good catch. I screwed up. That is on the 0.05 side, not the 0.10 side. So I got to replace that 0.10 with 0.05. Thank you very much. Casey, why didn't you tell me that? You're really slacking tonight, man. I think he's sharking me. Okay, so we're actually going to get 548,956. 0.43. So because of the lower rate, we actually need more money to make that happen. Now what? Well, now we need to use that number as the amount to be divided by how many years on the front side? Careful. 37. You got it. Times 12 would be 444. Is that look right? Yep. Wow, that seems cool. So 444 minus 1. Close divided by open. 0.10 divided by 12, close and close. Since we're paying in here, we don't need the extra term. So we take that number divided by 1, 2, 3. 1 plus 0.1 divided by 12, power of 444. Minus 1. Close divided by open. 0.1 divided by 12. Close and close. 117.81. So that's not bad to paying $120 a month and end up drawing out $4,000 a month later. Guess what? If you can do all that, you're ready for the test next week. Anybody have anything else they want me to go back over more?
I have a question.
Yes.
Why can't you take your whole amount right now? Why do you have to draw?
You could take the whole amount all at once instead of drawing it out monthly. It's just then you don't get any more interest on it. If you draw it out monthly, you get interest on it and it lasts longer. Big party.